Over the years of my software development journey, there is this one project that I could never get to work, no matter how much I tried. As a result, I always ended up dropping it. But as I was gaining experience over the years, the more times I tried it, the closer to the solution I was getting. It took different forms as I tried to get a new angle every time I picked it up. But the problem remained the same. How the hell do I make a text input area which allows me to style individual nodes inside of it as I wish? Hey everyone, I am the Ordinary Dev and this is my solution to the above problem. By the way, since you are already talking about my problems, I am trying to get to 500 subscribers, so a sub would be really appreciated. Thanks. To explain the monstrosity of a code that I have written, it made sense to divide these into 3 different sections. Code input area, which contains syntax highlighting and managing number of lines. The output area, which compiles the code and produces the output. And finally, the terminal, which takes care of error detection. Alright, so the first topic and probably the most important one, our main input area. To tackle my problem of an input field, I have decided not to use an input field. Instead, we will use a div and make it behave like an input field using a property called content editable. Now to understand this property, head over to any website like Google and in the console set the content editable property to true. Now you can click on any text and edit it as you like. Cool, right? Well, not quite. It's still not a perfect input field as we like, but first you need to understand the flow of syntax highlighting. So we start with typing something in our content editable div. Next, as soon as we detect a keyword in our text, we wrap that up in a span, give it a certain style and inject it back to our div. But wait, how are we going to detect a keyword? JavaScript alone has over 100 keywords and operators. Well, we have a library called Prism.js to do that for us. All we need to do is pass it a plain text and it will return our styled HTML. So here is what our pseudocode looks like till now. First, take input. Second, on every update, transform text to HTML using Prism.js. And third, inject the HTML in our input field. As I was celebrating my short-lived success, reality hit me when I tried to run the code. I noticed that after step 3, that is injecting our input field with HTML, the cursor always went back to the start. So I tried to know the root cause. I found that in our initial plain text, everything was a single node, that is text. But the HTML that we inject is not the same. In fact, it consists of multiple nodes combined together like text, span, etc. So the div has trouble translating the cursor position from the plain text to the new hypertext where multiple nodes are present, resulting in the cursor position going back to the start. This led me to modify our code to add in these changes. So after we take the input, we record our cursor position and then we apply the changes and we restore the cursor position. So this is what our pseudocode looks like after that. Now that you guys know the flow of syntax highlighting, let me translate that into code. So as we mentioned in the pseudocode, our first step is to take input. So we simply get the content of our input area like this. Next, we need to record our cursor position. To do this, let's say we have our cursor at this position. But since this text already contains some highlighted nodes, we can't simply get the cursor position. So in order to calculate that, we will start by getting the initial node that our cursor is on like this. Next, we store the cursor position of that node in a variable called total offset. Now we simply call the main node.previous sibling method to go to the node before this and keep incrementing the offset until we get to the very first node. So at the end of this loop, we will get our total offset. Now that we have recorded our cursor position, we need to transform our text into HTML using Prism.js like this. This will return our style HTML so that we can inject it back to our input area, fulfilling our next step of the process. Finally, it's time to restore the cursor position to where it was before. Here we will follow the same process as we did to record the cursor position, but we will just invert the flow. So instead of going from nth node to the first node and adding the offset at every step, we will instead go from the first node to the nth node and keep on subtracting the offset until we reach 0. This will tell us exactly where our cursor was so that we can restore the cursor position in our input area like this. Now before you guys grab my collar, don't worry, this whole code is available on my GitHub. You guys can find the link in the description and go through the code yourself. I've put nice and clean comments over each block of code to make the process easier. Alright, now that we are done with syntax highlighting, we can now move on to next topics like calculating the output and detecting errors, which are much simpler. This block of code is responsible for executing our input, which is in text form, as JavaScript. Let me show you how. As you can tell by looking at the first line, we are basically creating a function and passing our text as the function's body. Now, in the next line, we use something called f.apply. Now this apply method basically takes our function and executes it, which leads to two possibilities. First, if it completes without any issues, nothing will happen and our code will continue. Second, if our code has some errors and it does not complete, then the code will break. So for this case, we always use this block of code inside our try-catch method. Now if you pay attention, neither of these cases give us an output. So to get the output, we need to handle our console.log statements, because they are the ones responsible for any output that you see on your terminal. So to handle that, first take out all the console.log statements in our code. Next, we execute the code, and whenever the console.log comes, we store its value and manually display it in the output like this. This results in getting output like we do in this example. Now, if for some reason the code is incorrect and goes in the B direction, we will know that our code has some issues and we need to run error detection. Which brings us to our final piece of puzzle, detecting errors. Here we will use a library called Esprit. The library does something very similar to what we did here when we created a function and executed the code. So similar to that, we wrap this in a try-catch block. Now the conditions are also the same. If execution is flawless, then the code will continue and nothing will happen. But if there is an error, then the try-catch block will catch it and give us an object containing the error details. We simply put the parameters that we want, like the line number, index and message, in a custom class and save it in our state. Then this is how it looks when we display it on the UI. Now you might ask, why did we use Esprit to get that error? We could have just used the functions.apply method to do the same thing for us. Well, that is true, but notice how we get the error object in the try-catch block. The error we get from Esprit has more details like index and line number, which is not present in the error object that we get from the apply method. Alright, since you guys stick around for so long, here is some bonus content for you. To calculate and display the number of lines in the editor, I use the new line character, that is /n. Number of new line characters is equal to the number of lines. Simple. So based on the number of lines that we get from this method, we simply update it in the UI. And by that, this video has come to an end. Once again, the whole project is available on my GitHub if you guys want to check it out. Thank you for watching, and I will see you in another amazing project. Cheers.